All right, guys, we're going to go on and get started with Chapter 6. Today is going to be the first part of, today is going to be the first part of Chapter 6. Chapter 6 will be the last chapter that we are covering before Christmas break. And Chapter 6 is mainly going to be covering triangles. It's going to be, we're still focusing on triangles and relationships that they have. Now, theorem. The first theorem that we have is the perpendicular bisector theorem. In a plane, if a point lies on the perpendicular bisector of a line, then it's equidistant from the endpoints of the segment. Then these two lines are going to be congruent. If a point lies on the perpendicular bisector of a line that cuts it in half, cuts it into two congruent parts, and forms a right angle, then the two endpoints, the two lines connecting that point to that point will be congruent. These two lines will be the same. So let's look at an example of this here. So in this triangle here, we do have a perpendicular bisector, line SQ. And we know it's a perpendicular bisector because we have a right angle, and it cuts the line into two congruent parts. It is a perpendicular bisector. And if it's a perpendicular bisector, then the lines connecting that point to the two endpoints are going to be congruent. So SP is 6.8. So what's SR going to be? So the measure of RS is 6.8. Questions on this here? So let's look at the next one. Find the measure of CD. So we do have a right angle and two congruent sides, guys. So that would make this a perpendicular bisector. And if it is a perpendicular bisector, then the endpoints of the line connecting to point D are going to be congruent. So if AD is 27, DC is going to be 27. Well, the fact that it is a right angle, it is a perpendicular bisector, and it cut this line in half, that it is forming a right angle and cut it in half. Those two parts together, or put together, make it so that these two segments are going to be congruent. Any other questions on this here? Okay. Now we also have the converse of the perpendicular bisector. Now this is kind of going the other direction in that if we have a point that is equidistant from the two endpoints of a line, and it's on the perpendicular bisector, then it's going to lie on the perpendicular bisector. Really, if these two are congruent and we have a right angle still, then it's going to cut that line in half. So when we look at this here, because, for this example, because these two segments are congruent, the distance from that point to the line, to the two endpoints on the line, are the same, and we have the right angle, it means that these two segments here are going to be congruent. So EF is 9.5. So EG is not asking us for one segment, but the entire thing, which would be 19, because we're going to take 9.5 and add to it. So EG would be 19, because we have to add the two segments together. Any questions on this here? This one here is the next one. Now again, because these two segments are congruent and we do have the right angle, it means that these two segments here are going to be congruent. So PQ is 5, QR is also going to be 5. So PR is what? 10, because we have to add the two together. Any questions on this here? Let's look at the next one. So we want to find the length of AD. Now this time they didn't give us a measure, an actual number measure for either one, but they told us that CD is 3x plus 14 and AD is 5x. But what do we know about the two lengths? They're going to be equal. So if I want to find the length, we can just need to find the value of x first. Well, what can we do? We can set we can set 3x plus 14 equal to 5x, because we know that these two lengths are going to be the same. So once we set them equal, we can solve for the value of x, and then we will have to I would subtract 3x from both sides first, because on one side we do have 3x and 14, on the other we just have 5x. So it's going to be easier to solve this if we move all the x's to one side first. Here the 3x and 3x will cancel, and 5x minus 3x would be 2x is equal to 14. Then exactly, we would divide both sides by 2 to get that x is equal to 7. And that's it, yes? What's the question asking for? The measure of AD. So the length from A to D. Well, what is its length? 5x. So to solve this, we need to do 5 times 7, which would be, so AD would be, now did it matter which one we actually plugged, which equation we plugged it into? We do the same thing, because if we do 3 times 7 plus 14, exactly 3 times 7 is 21, 14 is, because again, we said those two side lengths are equal, they're congruent, so they should have the exact same value. Questions on this here? Let's do one more like this here. So we want to find the length of GH. Now it didn't tell us what the length of GH is directly or HE, but we do know that these two lengths are going to be congruent, because we do have a perpendicular bisector. So the lengths from the point H to E and H to G will be congruent. So the first thing we'll need to do is to solve for the value of x. So we can set 2x is equal to 3x minus 8. Then what can we do next? We would minus 3x. Because we'll need to subtract 3x first, because we need all the variables on one side and all the numbers on the other. Since one side already does have 8, negative 8 on it, we'll move everything to the other side. 3x minus 3x would be 0, leaving us with just negative 8. 2x minus 3x would be negative 1x or negative x, because we can write it as either way. But since x is negative, we need to make it positive by doing what? Negative 1. We can divide or multiply by negative 1. Because dividing by 1 doesn't change the number or change what it is. But negative x divided by negative 1 would just be x. And negative 8 divided by negative 1 is 8. So the value of x is 8. Now we do need to plug it back in. Which one of these equations would be easier to plug into? 2x, because we're just taking 2 times 8, and 2 times 8 is? And that would be the length of dh. And that's it. Any questions on this here? I don't know. Any questions on this here? All right, guys, if y'all feel comfortable with that, we'll go on to the angle bisector theorem. The angle bisector theorem and its converse are the last 2 theorems that we're going to look at. If a point lies on the bisector of an angle, then it's equidistant from the 2 sides. So if an angle bisected, if we have an angle that's bisected, and these 2 angles are both right angles, then we can say that these 2 lengths are equal to each other. And it'll actually work out that they are going to be equal every single time, as long as we have an angle bisector and these 2 right angles. We need those 2 components. We need both. So let's look at this first. Huh? Guys, use the information. So we're told that BD bisects ABC. And since it bisects this angle, it's going to cut it in half. These 2 angles are going to be congruent to each other. So since we have an angle bisected, and these angles are both right angles, it means that these 2 line segments are going to be congruent to each other. Now it also tells us that DC, the length of DC is 6.9. Guys, what can we say about AD or DA? So the length of DA is 6.9. And that's it. Questions on this here? Yes, ma'am? So, how can we do this one here?
This is the catch. 4x. Gotta do 4x equals to 2x plus 12.
Okay. And then what?
Then you would subtract the 2x from 4x.
Okay.
And that would be 2x equals 12. And you would divide. And then it would be 6.
So X would be 6. Jake, let's focus.
And then you take the 4x and you put 4 parentheses 6 parentheses, and it'll be 24.
And that would be the length of? And that's it. Mm-hmm.
I was trying to figure out what that was. It's a beard.
Are there any questions on this here? Do we need to see another example of one like this here? Okay. Let's look at this one here, and then we will look at the next theorem. So this one here, because of how it's set up, we do have an angle bisector, because that angle is cut in half. And we have our 2 right angles, so we can say that 5x is equal to 6x minus 5. The next thing we can do is do what? Minus 6x from both sides, exactly. Because 5x minus 6x is negative x. And it would equal negative 5. Do we get? And we could plug it into 5x, because that would be 5 times so RS would be 25. Any questions on this here? So this here would be the exact same thing. So the last theorem that we have for today is the converse of the angle bisector theorem. So if we're given this setup, now we need two things. First main thing is we need that these are both right angles. If we're given these two right angles and the distance to these lines are the same, BD is the same as DC, it means that this here is going to be an angle bisector. It means it's going to cut the angle in half. So it's almost, we're going the other direction from the previous one. Because in the previous one, we were given that it's an angle bisector and we have those two right angles. So the two lines are congruent. Here, the lines are already congruent and we have our right angles. So that means that these two angles are going to be congruent to each other. So here, we do have the two right angles, and we do have that these two lines are congruent. So what can we say about the angles? They're both going to be 42 degrees. It's going to be cut in half. So what's the measure of angle GFJ? 42. Now, it didn't ask for this, but what is the measure of GFH? Because we're going to take 42 plus 42, which will tell us that it is 84. As if we wanted to find the whole angle, we can just add the two together. So what about this one here? Well, those two lines are congruent, yes? We do have the two right angles, so would be
Hey, Mr. McLean,
Mhm.
I'll make a bet with you.
Okay.
If I make 100 on all of my assignments other than the test at the end of this section, will you grow out your beard? And like grow it out over Christmas break, and then whenever you come back, have it grown out?
Sure.
Okay. Are you extra determined to do them? Yeah, we'll try.
All right, guys, let's do one last one here. I think this is probably the last one on the sheet. So it tells us that AD and CD are both 3.2. We do have the right angles, and we're told that DBC is 39 degrees. So ABD would be 39. And we want to find the measure of AB. Because ABC would be the whole thing. So we would take 39 plus 39, which exactly would be 78. Any questions on this here? And that's it. Yes, ma'am. So there is, so let's look at the homework. You don't have to do 24. You're not doing 24. So it's 3 through 18. 3 through 18. There are a few questions asking if you can be able to determine if it is a perpendicular bisector, and you're really just using the theorem that we started with, 6.1, the perpendicular bisector theorem.